So this video is going to be about networks and how it works and stuff like that. So we needed a network because back then each module needed to know what other sensors and other modules were doing. Imagine that ECU, TCM, TPMS, SRS, and other modules needed to know what the wheel speed sensor signal was. So back then they hooked up a wire from the wheel speed sensor signal to the ECU, TCM, TPMS, SRS, and many other modules. And this required a lot of wires and made it very complex, and this is only one sensor. And they were a lot, well, compared to today, there's way more sensors today compared to back then, but yeah, but they still came up with a network that only uses 1 to 2 twisted pair wires on the network and can send information on those wires to each ECU. So before we had a network, we had multiple wires from each sensor going to each module, and this made cars complex, heavy, and very hard to diagnose. After we implemented networking, we only used one twisted pair wire going from one module to another module. Other modules can connect to these twisted pair wires using its own twisted pair wires. This is called a bus type network. So we have different network configurations. So the first one is the bus type. In this system, you have a highway, which is the twisted pair, and each module can connect to this highway using their own twisted pair cables. So the fuse box also has its own terminating resistor, just like this ECM, and this is the highway where other modules can connect here to, speak with each other. So in this whole entire network, and we also have different, more than just one network. This is only one network, and we have like 3 to 6 networks in a car. So yeah, but this is only one network, and this is a bus type configuration, and the ACM and the fuse box have their own terminating resistor, and we'll get into why we need a terminating resistor later down in the lesson. But we needed to just basically like delete or stop any signals from being messed up. So basically that's why. Anyways, if the highway, this right here, fails, all modules lose communication, and if the module with the terminating resistor, like this ECM, fails, then the communication may fail or degrade. And if non-terminating resistor module, like one of these right here, they don't have any terminating resistor, like this ECM or this fuse box failed, then it doesn't affect the other communications. Only that module stops working, and it doesn't affect the others since it's not critical to the bus termination. So the star type in this network, the hub shares information with other modules. If the hub fails, the whole network is down. If one module fails, like one of these, it doesn't stop other modules from communicating. If the ring module, if one of these fails, then the whole network is down. Protocols, this is the name for the language computers speak whenever they are talking to each other. Protocols differ in speed and technique used. So we have CAN-LO, also called BCAN. This protocol operates at speeds of 125 kilobits per second, and this protocol falls into the Class B network. And we have the CAN-HIGH, also called FCAN. This protocol operates at speeds of 125 kilobits to 1 megabits per second, and this protocol falls into the Class C network. So, and then part 2 of the protocols, we have the FlexRay, fastest speed communication up to 10 megabits per second, used for electronic suspension, ABS, electronic steering, and etc. Most media-oriented system transport, this is fast speed communication up to 150 kilobits per second, used for navigation, GPS, audio modules, etc. This uses a ring configured network. If one of the computers fails or a wire is broken, the whole network is down. Network topology. Most vehicles are composed of 3 to 6 network topology. Each network has different speeds, low, medium, high. Speed categories are classes which network speeds fall in. Class A, this was 10 kilobits per second, which is now obsolete. Nobody uses this anymore. Class B, this class is 125 kilobits per second, used for windshields, power seats, rear defoggers, instrument clusters, etc. Class C, this is 125 kilobits to 100 megabits per second, used for ABS, SRS, ECM, TCM, etc. And this offers real-time communication unlike A or B speed categories. Class D, this is 1 megabit per second to 10 megabits per second, used for radar, ADAS, camera networks, etc. Gateway is where other networks talk to each other and send information. It's basically a translator between different speed networks. It's how other modules from other networks can speak to each other. So in this example, the gateway is the gauge control module. The BCM can speak to the PCM through the gateway. Since they are in different networks, they need a translator, which is the gauge control module, and that's how they communicate with each other. Modules communicate using zeros and ones. Each module has a CAN high and a CAN low wire. It's how they speak to each other. So 1 is when both CAN high and CAN low are the same voltage. They create a 1. 0 is when both CAN high and CAN low are at different voltages, 3.5 and 1.5. They create a 0. CAN high, this wire voltage ranges from 2.5 to 3.5 volts. CAN low, this wire ranges from 1.5 to 2.5 volts. Terminal resistors, these are resistors that are placed at the end of the bus network, usually on 2 modules, or it can be on 1 module on a fuse box as well. These prevent echoes and absorb signals within the module communication bus network.